Let's now talk about the quasi-static process. To understand this, let us first of all have a look at this figure given to us. Now this is a simple piston cylinder arrangement. So this is the piston, okay, which can move up and down in this cylinder. Alright, now what is new in this system? The new thing is that we have a weight on top of this piston which is exerting a force in the downward direction, and it has certain amount of gas inside it, which is our system. Alright, now you have two more things. You have these two stops on top. So these are the two stops. Alright, so which stops the piston travel no further than these 2 points. Alright, now what happens is, let us say that initially the gas inside is at a pressure P1, volume V1 and temperature T1. So P1, V1 and T1, okay, these are your initial points and can be said to indicate the initial state. And this state is under thermodynamic equilibrium. Very true. Okay, now what would I do? I would remove this weight. Okay, so first of all, by equilibrium I mean that whatever gas is exerting on this piston, whatever force the gas is exerting on this piston, the same amount of force is being exerted by the weight on top of the piston on the piston surface. Okay, so these two forces, they negate each other, so that is why the system is under equilibrium. The system is going nowhere. There is no spontaneous change occurring in the system. Okay, now what would I do? I will remove this load. Let me remove this load. So after removing the load, what happens? The piston, it moves up suddenly and it hits these two stops. So your piston will now reach here. Now the movement of piston is also indicating that the system is now moving away from its equilibrium state. Alright, so this is an equilibrium state. So as soon as you remove the load on top of the piston, there is a force imbalance between the system and the surroundings, and the piston moves upwards and it deviates away from the equilibrium state. Okay, now after it hits the stops, the system stays there and it eventually attains the equilibrium state again. Okay, so let us say after attaining the equilibrium state, the system inside, let us say this is the new system now. Okay, the new pressure, volume and temperature would have now been attained. So this is the value of new pressure P1, P2, V2 and T2. So you will have P2, V2 and T2. These are the properties of the final state. And this is also a state under equilibrium. Okay, now what is the point to be noted down here? The states that the system passed through while going to the state number 2, all those states were non-equilibrium states. Okay, and because they were non-equilibrium states, we cannot plot this process, that is going from equilibrium state 1 to equilibrium state 2 on a thermodynamic coordinate plane. Means we cannot plot a PV diagram for this particular process, because although the initial and the final states are equilibrium states, the intermediate states are not equilibrium states. Okay, so you can have this as state 1 and this as state 2. Okay, so I don't know that how to plot the intermediate states that you get while going from state 1 to state 2. So these dotted line, these dots are basically the non-equilibrium states and they have no meaning. Now, what if, let me draw this diagram again. let me draw this again. So this is the this is the cylinder that we have. Okay, and these are the stops. These are the stops. This is the piston. Alright, so this is the piston. And now let me keep one weight on top. Earlier also it was one weight, but now this complete weight is divided into very small parts. Very small parts. Alright, so this is single weight. The single weight, but these are very small weights. So let me write these down. So these are very small weights. Okay, now the system inside again has the properties P1, V1, T1. Now this is an equilibrium state. Now what will I do? I will remove one plate from the top. When you remove one plate from the top, there is a slight, a very slight movement of this piston from this point to this point. But this movement is, not seen by the naked eye, because the imbalance that we are creating is very small. It's very small. You hardly see this change occurring from this point A to the other point B. So you can say that this initial state is an equilibrium state, and the state that it attains after the first part of the weight is removed, it is also in equilibrium, because nothing has changed. Practically the pressure, volume and temperature are all same. Okay, and you keep this you keep doing this very slowly. You keep on removing all these weights one by one, and all the states that you attain in between as the system passes through and hits the stops, all these states C, D, E, F and so on, all these states are equilibrium states. Okay, now the benefit of having equilibrium states is that you can actually plot these states on a thermodynamic plane. So I can have a PV diagram out of this process. So I can have state 1 over here. Let us say state 2 is here. So when I draw a diagram, when I draw a process like this, I can actually draw a straight line, because all the states that would have been passed by the system, alright, all the states that the system passed while going from 1 to 2, everything or every state was an equilibrium state. Okay, so such a process that is a locus of, so this is nothing but a locus, a process which is the locus of all the equilibrium points that are passed through by the system, is known as quasi-static process. Now what is the meaning of quasi-static? Okay, now quasi means almost, and static means at rest. Now although the system has moved from point A to this point, let us say Z, this has been the movement, but the system has not shown any considerable spontaneous change. It has been almost at rest. So this process occurs infinitesimally slowly. The process occurs infinitesimally slowly. So this is a very important characteristic of a quasi-static process, that is, it has infinite slowness, and it is a succession of equilibrium states. Okay, due to this nature of it, a quasi-static process is also called a reversible process. Now what is a reversible process? That is, when you go from state 1 to state 2 along this path, you can actually come back from state 2 to state 1 along the same path, having the same states occurring again. Okay, so that is called a reversible process. Alright, so we'll talk about reversible and irreversible in a different video. So this was all that I wanted to talk to you about the quasi-static processes. Now after this, let's go on and talk about the last topic of the introductory video on thermodynamics. That is, we'll talk about pressure, different types of pressures, and the relationship between those different types of pressures. Thank you.